Welcome to Agile and Ease of EDA Demo Fast Cosim, Converging Accuracy and Speed. Before proceeding with the demo, let's first establish why we need co-simulation and then what is Fast Cosim. Full transmitter and receiver simulations, whether it's for design or verification, includes system-level behavioral model at the baseband and also circuit-level transistor designs. These simulations also include measurements such as ACPR, EVM, and bit error rate, which may take a long time to simulate. Fast Cosim is a process where a behavioral model is generated on fly using harmonic balance simulator and used at the system level. This model can be compared with the circuit envelope simulation if the user desires so. In this demo, we will describe simulation of a TD-SCDMA transmitter. We will simulate the error vector magnitude due to this transmitter, and also we will include a transistor level circuit in the simulation to do the co-simulation. We will compare the results obtained on the accuracy and speed between the Fast Cosim and Standard Cosim. With the schematic template available to us, the next step is to insert the device under test between the transmitter and the measurement. We go to the library, select the subnetwork, and pick the particular design that we've already created and place it between the transmitter and the measurement. If we push into this particular circuit design, we see two levels of hierarchy. At the lowest level, there are transistors, lumped elements, and also distributed elements, plus the substrate definition. One level higher, we see the simulation controller and also the BIOS configuration. We come up and we notice that we also configured a parameter called Fast Cosim, and we can set this to yes or no and start the simulation. We start with no, disabling the Fast Cosim. At this stage, we use an envelope out selector component and place it right after the circuit design. All this component does is define which frequency is being pulled out at the system level. In this case, we would like to specify a carrier frequency, so we use a variable F carrier which is set to 1.9 gigahertz. Next thing we have to do now is to begin the simulation. Simulation is now completed. The status results show that EVM analysis for 10 subframes of TD-SCDMA takes roughly 530 seconds to be completed. Now let's change the Fast Cosim option to yes and initiate simulation. Now this time, the status for the simulation is going to be completed much faster, and the simulation is already done in only 24 or 30 seconds total, the same number of subframes. Now we go back to simulation results. These are detailed EVM simulation results indicating EVM RMS as well as composite EVM as a function of subframe. To take a look at these results graphically, we go to another page of data display where we have compared the channel EVM and composite EVM for peak and RMS graphically. These results indicate that both simulations, the trends of EVM as a function of subframe follow closely, and also the fact that error for example for peak EVM is below 0.02%, which is very accurate as far as what's needed. In summary, we learned that fast Cosim provides accuracy and speed. Accuracies of better than 99% are typical, and speed improvements of 10 to 100x or higher are common. In this slide, we've shown 3 cases of speed-ups for 3GPP and wireless LAN. Thank you for watching this Agile and ESOF EDA